Let me begin by asking, does anybody have any specific question that they want to ask?
Just about the previous assignment and this week's assignment.
Okay, the assignment on hypothesis testing for the machines?
Yes.
Okay, all right. So I'm going to, first of all, go through the process of hypothesis testing, and then I'm going to do that particular assignment. The assignment has three parts, essentially doing the same thing 3 times over. So I'm going to illustrate with one of them as an example, and then you can do the other one. Then I'm going to also continue with test of hypothesis for 2 populations, and expect that you can then apply the method to the homework assignments. Now, the homework assignment has 2 parts doing the same thing twice over or 3 times over. Then I'm going to just do one of them as illustration so you can do the rest. So the first thing I'm going to do is to screen share. I'm going to screen share so that we can see exactly what we're doing. All right, so let's see. All right, so you can see my screen?
Yes.
Yes.
All right, okay. I'm going to see if I can make it a little bigger. All right, so let's, so the first thing that we need to understand about the problem is a test of hypothesis, okay? And we're going to do 1 sample hypothesis test, and then 2 sample hypothesis tests, or you can say 1 population hypothesis test and a 2 population hypothesis test, okay? And so by the time we are done, you can define hypothesis properly, because this is something that students very often are not able to do. I was once a student, so defining a hypothesis properly is very, very important. And then we're going to apply the 6-step procedure for testing a hypothesis, and try to distinguish between a 1-tailed hypothesis and a 2-tailed hypothesis, okay? All right, now, what is a hypothesis? A hypothesis is a statement about a population parameter and subject to verification. Now, that's a technical statement. It's a statement, or actually a claim, about the characteristic of a population, okay? And the claim is subject to verification using data, all right? For example, you can say, and I'm going to add some additional examples here, okay? Say the average, the average age of houses in Brooklyn is 80 years. Okay. That is a statement about the characteristic, okay, that you can make. Okay. And then what you do then is that you use data on the age of houses in Brooklyn. You take a sample of data. You can get the entire population. If you get the entire population, then you don't need to test a hypothesis, okay? So if you take a sample of data, then you can use that sample of data to test the hypothesis that the average age of houses in Brooklyn is 80 years, okay? A machine is expected to produce 595 units per day, okay? What does that mean? It means that You can take a sample of days. Some days it produces 580, some days it produces 620. And so you take an average and see if the hypothesis, if the data supports your hypothesis that the average number of units that's produced per day is about 595. Okay, you can say consumers prefer Coke over over other cola drinks. All right, and so here is a test of proportion. Billboard advertising is more effective than advertising in paper-based media, and so forth and so on. So these are examples of a hypothesis. This is a statement, it's a claim about a characteristic of a population. All right. And so the steps are easy. You state a hypothesis. And the way hypothesis is stated is to state a null hypothesis. Okay, and I'm going to write that null here. Let's see if we can get it there. Okay, you state a null hypothesis. Okay, a statement about the value of a population parameter. Like I said, the average age of houses is the parameter here is average. Okay, okay, it's average, and the value of the population parameter is average of 80. So 80 is the value. Okay. And then you subject that to a test. And so the null hypothesis is represented by H0 or H0. And then you state the alternate hypothesis, okay? So the alternate hypothesis, and to say the average age of houses is not 80. That is an alternate hypothesis. Or you can say the average age of houses is greater than 80, or the alternate could be the average age of houses is less than 80. Okay? So now the alternate hypothesis must always have the equality sign. Okay? For example, you say the null hypothesis is that average equals a 0. And that's an example of a null hypothesis. Okay, that's an example of a null hypothesis. Okay, and the alternate would be that it's not. All right. The next step is to select a level of significance. Okay, level of significance, and then you identify the test statistics, which is to calculate a z table. Okay, I mean a z value. To calculate the z value. So let's go through the process. Okay, now you say that the production machine is designed to produce 595 units per day, and you take a sample of 38 days, okay? And when you take a sample of 38 days, you don't expect to get exactly 595, okay? You could get something less than 595, you could get something more than 595. In this particular example, we got an average, we got an average of 625, and we have a standard deviation. And so we say test the hypothesis at 0.0 level, at 0.01 level of significance, that the machine meets or exceeds the output expected, or the expected output. So now we're going to test whether the machine actually produces an average of 595 a day, or maybe produces more than 595 a day. Okay. All right. So we collect a sample of data, and in this particular example, the sample size is 38. Okay, we calculate the sample mean, and the sample mean gives us 625. We calculate the sample standard deviation, which gives us 65.55. And I'm going to go through an actual example to show what we mean. Okay, we state the level of significance of, say, 0.02 or 0.01, okay? So I'm taking 0.01, okay? And you remember, last time we looked at the normal distribution, okay? So if you take a level of significance of 0.01, realize that then this is half of the distribution equals 0.50. And this then means that mean lies within 49% of distribution. Now let's go back then and ask ourselves, how do we then select? Okay. How do we then come with a Z star? We select a test statistic, and we call that the critical Z, okay? Which this is called the critical value. Okay, so how do we select this critical value? Okay. Now, how do we select this critical value? I will go back to the distribution, and let me see if I can find one conveniently here. Okay, we cannot find a convenient one here, so I'm going to go get one so that we go back to what we understand. Okay, so how do we select? Let's look at the critical value here. Okay, so do you remember this table?
Yeah.
Okay.
Yes.
All right. So if you have at this tail end of the distribution, this right tail end, you can see the unshaded area, or if you take it on the left side, whichever way you take it, if 0.01, which is 1%, is at the tail end, therefore you must have 49% in the interior. Am I correct?
Correct.
Okay. Because half of the distribution is 50%. So if you have 1% left out, what is remaining in there, that particular half of the distribution has to be 49%. Okay? So we go now to our table here, and we look for 49%. We have 0.4901. Do you see that?
Yes.
Okay. So the corresponding Z value is 2.33. If you come down here, have 2.03, and you have 2.3 here. So it's 2.33. That is how we got the critical value of Z. Is that clear to you?
Yes,
Yes.
it is.
Okay, that's how we got that critical value here of 2.33, because we have a 1% level of distribution. And if half of the distribution is 3%, that means that the mean lies within 49% of the half of the distribution. So we'll go there and look for 0.49, and then the corresponding Z value to that 0.49, which is 2.33. If you have any other distribution like, say, 0.025 or even 0.02, if you have 0.02, for example, and then if you go back to the table, if you have 0.02, that means 48% of the distribution is in the interior. And so you come in here and look for 48%, and the closest is like 0.4798 or 0.4803. But let's take 0.4798, which is very close. So then you have 2.05. That will be your critical value. Is that clear?
Yes, it is clear.
Yes.
Okay. That will become your critical value. Your critical value will become 2.05 because you have 2% out there as in the extreme tail. And so you have, that means you have 48% left in the interior and in the remaining part of that half. And so your critical value will now be based on 2.05 as 48%. 48%, or you can take 2.06. If you take either of them, you will not be wrong. All right? Okay, so we determine a critical value of 2.33, and then we calculate a Z value, okay? So we calculate a Z value, and Z value is calculated, that is, we have a critical Z value, okay? So we'll call this the critical Z value, okay? So this critical Z value is selected from a table. Then you calculate your own Z value, which is called the calculated Z value. All right? So there's a critical Z and a calculated Z. So now your decision rule to reject or not reject the null hypothesis, okay? So when you state the null hypothesis and the alternate hypothesis, your objective is to see if you can reject the null hypothesis, all right? And so the decision rule is that if Z, the calculated Z value, is greater than or equal to the critical Z value, then you reject the null hypothesis. And when you reject the null hypothesis, you are now saying that the alternate hypothesis seems to be true, okay? All right, so let's then move on to the next, the example then. And so your hypothesis, which is the null hypothesis, is that the average is 595. That is your null hypothesis. Okay, do you recollect that? Hello,
Yes.
friends? You recollect
Yes.
that? So that's the null hypothesis. You are making a claim that the machine produces 595 on the average, okay? And then the alternate hypothesis, which is a one-sided hypothesis, you know, take note that this is a one-sided hypothesis because it is not saying that the machine does not produce 595. It actually states that the machine produces more than 595. So that is your alternate hypothesis. And the reason you state the alternate hypothesis to be more is because your sample mean is 625, which is more than the null hypothesis. So you already take that position that the machine produces more than 595, okay? You state your sample standard deviation, you know your sample size, your critical Z is 2.33, and then your calculated Z is 2.821, which is based on a calculation of X bar, which is your sample, minus your null hypothesis, which is 595, divided by the standard deviation S, over the square root of n, okay? And so 625 minus 595 divided by 65.5 over the square root of 38. So you do this calculation separately, okay? And what you get is 2.821, all right? If you have your calculator there, try to verify what I just got there. And so your decision rule is that if z, which is 2.821, is greater than the critical z, which is 2.33, then you reject the null hypothesis that the machine produces an average of 595. So you reject that null hypothesis, you are concluding then that the machine produces more than 595, okay? You reject the alternate hypothesis, and so you reject the null hypothesis, then you accept the alternate hypothesis, okay? So your conclusion is that machine produces greater than 595. Is that clear?
Yeah.
Yeah.
All right. So let's go and look at the example that you talked about in the homework assignment. So we have gone through what do you call it? An example of hypothesis testing. And we're going to apply it to the homework assignment, okay? There's going to be quite a bit of critical thinking here, okay? All right, because when you go out there in the actual, in real world, you will not see a situation where they just give you the numbers like that, okay? You have to define the problem and okay, so I'm going to stop share this. I'm going to stop this share. And let's look at the problem that we're supposed to solve. Let's see. Okay. I'm going to screen share. I believe this is the problem that you are talking about. Hello, friends. Okay, let me see if I can pull up. If I can pull up
the example.
No, this is the homework assignment you said to talk about how we're going to solve it.
Yeah.
Okay. So let
Wait,
me
it's about machines. It has a table.
Yeah, this looks like the example that you gave, Professor. Is this the
Yeah, I
example
don't
that
think
you
that's
gave
the
us?
same
I think that's the
thing.
example.
Yes, let's see. I know what she's talking about.
Yeah, the one something about Jim or somebody, John, in the same machine.
Yes, it's the machine problem. Let's see. Yes, machine records. Okay. I mean, I kind of like solved it partially, and but I'm going to okay. All right. Let me pull up the assignment and then. All right, you can see my screen now.
Yes, this is it.
This is it, right?
Yeah.
Okay. All right. So let us look at how we could solve it. Okay. So this is why I said there's going to be some kind of critical thinking, right? Suppose you were to take this problem. Suppose you were a manager. Don't even have to be the production manager yourself. Okay. If you were the production manager, of course, you would set up the problem this way. Okay. Says there are 3 machines, right? Are you following me?
Yes, Professor, yeah.
Okay.
Yeah.
Now, the 3 machines are expected to produce, or they are designed. They are designed to produce, if machine number 1 is designed to produce 700 units per day. You see that?
Yes.
Yes.
Okay. And machine number 2 is designed to produce 200 units a day. Or per minute, not per day, per minute. Machine number 3 is designed to produce 500 parts per minute. You get it?
Yes, I understand, Professor.
Okay. Very, very good. Okay. Now, we have selected records, okay? And what is this problem asking us to do? Okay. What is this problem asking us to do? The machines were scheduled for a shift of 7.75 hours for each day. All right. All right. Now, the question is, the machines, if the machine produces 85% of its design, like this one is designed to produce, machine number 1 is designed to produce 700 units per minute. Am I correct?
Yes, you're correct.
Good. So, but if it makes 85% of its capacity, then we will say that it's doing its job.
Correct.
Very good. So now the question is, use your calculator and calculate 85% of 700. What does it give you?
Okay.
$595.
595. You see how I got that 595?
Yeah.
Okay. So when you set your null hypothesis, you're going to be saying mu is equal to 595.
Okay, got you.
You get that?
Yeah, I got that.
Okay, very good. So now, the next thing that I'm going to do is to ask ourselves, does the machine actually produce an average of 595? So let us see. I'm going to stop share and I'm going to pull up the data. You know, your homework assignment is not going to require you to do all of that. Okay. But I'm going to pull up the data. Okay.
We're using Excel for this assignment, right? Even though it said you gotta make a report.
Yeah, but when I'm done, I'll let you know whether you're going to need that Excel.
Okay.
Okay, here is the raw Excel data, right? Okay, so now the thing that you need to do is to calculate for yourself the average production of the machine per minute, okay? So I'm going to call this QPM, the quantity per minute, right? Or you can even say ppm because it says parts per minute. And so this is machine 1. This is machine 1. You see machine 1 here?
Yes.
Yeah.
Good. So how many parts does machine 1 produce per minute? Well, this particular unit of the machine, on this particular day, the machine was running for 7.75 hours, right? And so 7.75 hours is equal to what? 7.75 times 60 minutes. Am I correct?
You're correct.
Okay, so we're going to say equals C2 over D2 times 60. Okay, so on this day, it produced 688, and you can drag that down. All right. Okay. So this is for the number of days. Here we have 28 days. It produced these various number of units a day. So I'm going to get an average. Okay. So this is the average. So what average did we get there? We get an average of 639 per day. So this is how we do the calculation. Okay, I mean, I use 625 there arbitrarily, but you can see you calculate the average. Is that correct? And you calculate the standard deviation. Okay. Calculate the standard deviation equal to sample standard deviation T dev S.
Well, I think you have to double click it, the formula.
Equals, let me just take it from here. All right. So we get a standard deviation of 60.448. This is, if you were to do this problem from scratch, this is what you would do. Okay. You calculate an average, you calculate a standard deviation, and then you go through the process that I showed to you. But what I have done is to make it simpler. I might still give you a homework assignment that requires you to go through this process. So now there are 3 machines, okay? So you calculate 85% of the rating for machine 1, you calculate 85% of the rating for machine 2, the same thing for machine 3. And then you calculate their standard deviations, and you test each of them separately, all right? So, but this is what I did for this problem. Okay, so what I did was to essentially provide you the information. So machine type 1, okay? The test value, which is your null hypothesis, is 595. You see that?
Yes, I see that.
Yes.
Good. So you have a test value. So you will simply state null hypothesis mu equal to 595. All right. And then you have as a matter of fact, I didn't even take you through to calculate the standard deviation. So you have the calculated, this is the Z value. It's called T. When the computer prints it out, it calls it T. So that's your Z value. So it gives you a Z value of 3.858. All right? You get it?
Yes,
Yeah.
Professor.
So it calculates the Z value for you. But now what I want you to do is to select, is to set the null hypothesis the way I stated it, and then to select the critical Z value that you would use. And then compare the calculated Z value to the critical Z value and give me your conclusion.
Okay.
Okay? Now
Okay.
here
Do you mind
is,
repeating that again?
okay. You know, we went through the process. I'm going to pull up the PowerPoint slides again. Hope this is the right one. If it's not, I'll change it. Okay. Oh. Are you seeing my screen?
Yeah.
Yes, I can.
Okay. You see, we selected a critical Z value. Am I correct?
Yes.
And we calculated Z value.
Mm.
And we compared the calculated T to the critical T. You see that?
Mm.
Very good. So what I want you to do for this problem
Mm-hmm.
is, here I've given you the null hypothesis. So you simply state, you follow the procedure and say mu is equal to so and so. Now the PowerPoint slide is there for you to download and follow the process. Is it the PowerPoint slide? It's there in Blackboard.
Okay.
Yes.
Okay,
Yes.
it's there in Blackboard, so you just pull it down.
Mhm.
Okay.
Okay.
So you simply say that mu is equal to 595. The alternate hypothesis is that mu is greater than 595, you know, since you have the sample statistic. And then you select, I want to see that you know how to select the critical Z value, because I asked you to test at what level of significance. I did not even give you a level of significance, and so you can actually choose your own level of significance. Okay?
Okay, Professor.
Yes.
The other homework that you showed me before you did this one,
Okay.
is that also what we're supposed to do along with it? Because I thought it was just an example that you showed us.
That's an example.
Okay.
Okay? This is the
Okay.
one it's supposed to do.
Okay.
All right? Okay. So you state your null hypothesis, you state the alternate hypothesis, you state a critical Z value. I'm going to go and actually give you a critical value there. And then you take the calculated Z and compare it to the critical Z and give me a conclusion. So the first machine is the 85% of 700 is 595. 85% of for machine type 2,
200.
okay, 85% of 200 is 170. And the other machine, 85% of machine 3 is 132. So your null hypothesis is already given to you. You get the point?
Yeah.
Okay. And then if you want to do the problem from scratch, this is the sample mean. This is the sample standard deviation, which we got, when we did the calculation ourselves. Like I said, the 625 I used in the illustration was an arbitrary number just to illustrate the point. But if you want to see the actual numbers, they are already given to you here. You could calculate them from scratch, but I already gave them to you here. You have your sample mean, you have a sample standard deviation, and you can go through the entire process using the PowerPoint slides.
Okay.
Okay.
Okay, but you have to do it for each of the machines.
Okay.
So everybody's followed it right now.
Yes, I have.
I'm
Yes.
going to give you a level of significance that you can use. I'm just going to use 0.05. So so that's essentially what it is. It's just that you have to calculate, the mu, that is the null hypothesis yourself, by taking 85%. I mean, other problems will take different forms, but this is the critical thinking part of it. When you ask, is the machine doing its job? If the machine is not doing its job, that means the machine is not producing at least 85% of its design capacity. It's designed to produce 700. And so if it produces 85%, we say it's doing good. You get it? Now,
Yeah.
you see here that the t-value here is negative. Ignore the negative sign. You hear that?
Yeah.
Ignore the negative sign. Use the absolute values. All right? Okay. Any other question?
No, that's it.
Okay. So next week, we're going to talk about hypothesis testing for two populations. I need for you to digest this. Your homework assignment is open. Go and make sure that you get it done before this weekend is over.
Okay.
Will you be pushing back module 4?
I will push back every module.
Okay.
We're gonna catch up, but I'll push back module 4. Yes, I will.
Will you like change it in the Blackboard just so it shows?
Oh, absolutely.
Okay.
All right. If I don't change it, just let me know. If it closes,
Okay.
let me know.
Okay.
All right.
Thank you.
Okay.
Yeah.
Okay, guys. Good night.
Okay, good night, Professor. Thank you.
All right.
Night. Thank you.